Hello students, welcome to TIME online classes. Today we are going to deal with the topic 3D geometry. We are going to study how to find out the foot of the perpendicular and mirror image of a point with respect to a line. You might have heard about foot of the perpendicular of a point with respect to a line. So this actually is a tedious process to find out the foot of the perpendicular as well as the mirror image. I'm going to give you a shortcut formula to find out the foot of the perpendicular and mirror image. Before that, let me explain what is actually foot of the perpendicular and mirror image. Let's look at this figure. Let P, x2, y2, z2 be a point on the plane and L be the line in the plane. So if you draw a perpendicular from P to the line, it will meet at the point F, which is x, y, z, and this F is the foot of the perpendicular. So when you join P with F, the point at which the line FP meet at L is called the foot of the perpendicular. Now P dash will be the mirror image of the point P with respect to the line L. So we can see that FP and FP dash will be equal in length. That is, the distance between F and P will be same as F and P dash, and F will be the midpoint of P and P dash. So we are trying to find out the mirror image as well as the foot of the perpendicular in the easiest way. Let me explain the formula first. Consider the point x2, y2, z2 and the line x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. The foot of the perpendicular is obtained using this formula, that is x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c equal to lambda p, where lambda p is a into x2 minus x1 plus b into y2 minus y1 plus c into z2 minus z1 by a square plus b square plus c square. We already know what is x2, x1 and a, similarly y2, y1 and b, and z2, z1 and c. So substituting in this equation, we can find out lambda p. Once we get lambda p, we can rearrange x minus x1 by a with lambda p to find x. Similarly, y minus y1 by b with lambda p to find y, and z minus z1 by c with lambda p to find z. So once we get x, y and z, we get the foot of the perpendicular. Now once we get the foot of the perpendicular, as you know, foot of the perpendicular is the midpoint of P and P dash. To find the image, we'll use this idea. So the foot of the perpendicular is the midpoint of P and P dash. So using this idea, image will be 2 times foot minus the given point. So 2F minus P. This is how we find the image. Now let me explain this using a sample problem. The reflection of minus 2, 0, 3 in the line R is equal to 2i plus j minus k plus lambda times 3i plus 3j minus k is z. So we have to find out the reflection. As you know, reflection is nothing but mirror image. Okay, so we are trying to find out the mirror image of the point negative 2, 0, 3 in the line R is equal to 2i plus j minus k plus lambda times 3i plus 3j minus k. So first, let me explain how to write this vector equation in the Cartesian form. So suppose if we are given R is equal to x1i plus y1j plus z1k plus lambda times ai plus bj plus ck. this is the vector equation given. We are asked to find out the Cartesian form. So first I am trying to form the Cartesian equation. So if you want to write the Cartesian equation, you have to write like this: x minus the coefficient of I. So x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. So you just have to rearrange. Take x1 to the left hand side and divide by a, take y1 to the left hand side and divide by b, and take z1 to the left hand side and divide by c. So this is how we form the Cartesian form. So now look at the previous side. We are done with the left hand side of the foot of the perpendicular. We are assuming that x, y, z are the foot of the perpendicular, and we are forming the left hand side. We are just rewriting the given equation, and that will give you the first part. And then we have to equate this with lambda p. So in this given equation, let's write it in the Cartesian form. So how will you write it? X minus 2 divided by 3 equal to y minus 1 divided by 3 equal to z plus 1. Look at this. This is minus 1. So when it goes to the left hand side, it will become plus 1 divided by negative 1. So we are done with the formation of Cartesian equation. Now with this, we are going to equate this with lambda p. So before forming lambda p, let us identify what is a, b, c, x1, y1, z1 and x2, y2, z2. So here a is 3, b is again 3 and c is negative 1. Similarly, x1 is 2, y1 is 1 and z1 is negative 1. So we already got what is x1, y1 and z1. Now x2 is negative 2, y2 is 0 and z2 is 3. So here a is 3, b is 3, c is negative 1. x1 is 2, y1 is 1, z1 is negative 1, x2 is negative 2, y2 is 0 and z2 is 3. So let us substitute and find out lambda p. For this, a into, what is a? 3 into x2 minus x1, that is negative 2 minus 2, that is negative 4, plus b into, that is 3 into 0 minus 1, that is negative 1, plus c into, that is negative 1 into 3 minus negative 1, that is 4 divided by 3 square, that is 9, again 3 square 9 plus negative 1 square, that is 1. So on the right hand side we have negative 12, negative 15, negative 19. Negative 19 divided by 9 plus 1, that is 19, will give you negative 1. So now we have already formed the base for finding the foot of the perpendicular. Look at this. I have already written this part, that is x minus x1 by a equal to y minus y by 1 by b equal to z minus z1 by c equal to lambda p. So we have formed with this, and already we have found the value of lambda p. Here lambda p is negative 1. So we have to identify what is x, y and z. So x, y and z will form the foot of the perpendicular, and once we get the foot of the perpendicular, we'll find out the image. So to find the foot of the perpendicular, I'm first going to equate x minus 2 by 3 with negative 1. So what do we get? X minus 2 equal to negative 3. So x is negative 3 plus 2 will give you negative 1. Similarly, y minus 1 by 3 is negative 1. So y minus 1 equal to negative 3. So y is equal to negative 3 plus 1 will give you negative 2. And finally, z plus 1 by negative 1 will give you negative 1. So z plus 1 equal to negative 1. So z is equal to, positive 1. Z plus 1 equal to positive 1. So z is equal to 0. So we got the foot of the perpendicular, okay, foot of the perpendicular is equal to -1, -2, 0. Now we have to find out the reflection or image reflection. The reflection is given by 2 times foot minus the given point. So 2 into -1, -2, 0 minus given point is -2, 0, 3. So let's simplify. What do you get? -2 plus 2 will give you 0. Now -2 into 2, that is -4 minus 0 is -4, and this is 0 minus 3, that is -3. So foot of the perpendicular is given by 0, -4, -3. So let me just recap the formula once again. X, if you want to find out the foot of the perpendicular from x2, y2, z2 to a line x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. The formula to find out the foot of the perpendicular is x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c equal to lambda p, where lambda p is a into x2 minus x1 plus b into y2 minus y1 plus c into z2 minus z1 divided by a square plus b square plus c square. Using this, we can find x, y, z, which is the coordinate for foot of the perpendicular. And to find the image, we'll use the property foot of the perpendicular will be the midpoint of P and P dash. So image will be 2 into foot of the perpendicular minus the given point. I hope you enjoyed the session. Thank you.